In this project, we look into using Bayesian mixture models to constrain important parameters regarding galaxy clusters. So just for some context, galaxy clusters are large clusters of galaxies that are bound together by their own mutual gravity, as well as a significant amount of dark matter. And one thing we're particularly concerned with is measuring the radius of these galaxy clusters. An important physically motivated radius that we use is the splashback radius, which is the point at which particles reach the epicenter of their first orbit. One limitation to calculating or figuring out what this splashback radius is our ability to correctly center individual clusters. And this is just due to limitations of observational data. So in this project, our goal is to figure out the degree to which, or come up with a way that can constrain what percentage of clusters are miscentered and to what degree they are miscentered. So the objective is to test a mixture model on simulated galaxy clusters to see if we can produce the correct amount of miscentering for these clusters. And we use simulation data because we can control what percentage of the clusters are miscentered and by how much they are miscentered. And then we see if we can reproduce that using the mixture model with these parameters. So yeah, that's the first step of our methodology is that. Then what we do is we pass in this mixture model likelihood into MultiNest, which is a nested sampling Monte Carlo method. And we do this in order to produce the most likely parameters for our cluster data. And this goes through, and it's a mixture model, so it goes through each individual cluster and takes the likelihood for being miscentered and non-miscentered in order to produce these parameters that measure that, right? Fmiss being the percentage of clusters that are miscentered, and sigma r being the width of the Rayleigh distribution that determines the probability of certain miscentering distances. And then we hopefully will return posteriors on F and sigma r that should match our inputted F and sigma r that we arbitrarily pick, and that would be able to test the model then. So we know the model works if it is able to reproduce the known and chosen F and sigma r. We expect that this will work. We have not fully tested it yet, but just due to other uses of mixture models in astrophysics, in similar scenarios and in galaxy clusters as well, we expect that this will work. Now and then, if the test is successful and we are successfully able to reproduce our arbitrarily chosen parameters, we will attempt to use the same method on observational data, and hopefully be able to constrain an accurate Fmiss and sigma r value for observation of certain clusters or certain sets of clusters. And that should be able to tell us by how much our observational techniques are miscentering them and how often they're being miscentered. And then this is important because this allows us to have more accurate results in measuring things like splashback radius and other physical properties of galaxy clusters. Thanks.